Hi, this video is to show the demo usage scenario 1 of DiffFit, fit a single structure interactively. We will follow the documentation here. First, we open Camera X, and then we open DiffFit. Then the first step, we need to open the source structure and the target map. We will use the PDB 6WTI and its associated CorelEM map 21897 as an example. There are two ways to open these files. The first one is to type this command, these two commands. Now we are opening the EM map. Then there's the other option that's you can open this link with you can change the last four characters to the other PDB ID if you want, and then go to download files, download the MMCIF format. You can download PDB format if you want, but we will make the tutorial in this MMCIF file. So download files, download this file, and then go to the EMDB database, or you can click find this EM map, EM ID here, and then click download. Download the 3D volume. And then you can unzip this volume. So similarly, if I close this files open from the command line, and if I drag drop, the order doesn't matter too much, because after that we can choose from here what we are fitting in. So you probably noticed that if we open from the database, it automatically changes to a better threshold, because in the database there is a recommended surface level threshold. So we will use that one. But DiffFit is very robust against this number, so we can try at this threshold level already. So we've shown this step. Now in this interactive tab, so there are different tabs for DiffFit. In this interactive tab, we choose a structure and we choose a volume, and then we click fit. So after a few seconds, on a RTX 4090, if you are running on a CPU, it might take a few minutes. Then DiffFit will automatically go to this view tab, where it shows the fitting result. Right now it shows only one plausible fitting, because we have set our threshold very high. If you make it lower, this in-contour threshold means the atoms that are within the thresholded volume, the percentage of those, and the correlation threshold is how well this structure aligns with the map. So if you make the in-contour threshold lower and the correlation lower, for example, and then we load the result again, it's again still, then if we further make it lower, so now we can see other fits, but those are not plausible. not feasible, so we don't have to take care of them. Normally the default threshold is 0.2 and 0.5, and we can see that if there is a plausible fit, it's gonna show up here. Then here we have a heads up that DiffFit should be used as a initial fitting, automatic initial fitting tool. Very often, the camera axis built-in fitting map tool or the command is giving a better result. So we can do that fitting again here and push that. So if you watch it carefully, the placement shifted slightly. So then we've gone through this step. We've also gone through this step. The equivalent command is fit number 1, that's the structure, in number 2, that's the map. We can try this command too. If we click it again, it will go back to the DiffFit placement. So, and now we are again using the camera axis built-in command to refine the fit. So if you have a ground truth structure to compare with, which we do have here, because we know the ground truth, so we can drop it in, and that's the third. The ID is 3, so we can use the command rmsd. We calculate the RMSD of the number 1 model, that's our fitted structure, to the number 3, that's the ground truth. So we will get the RMSD root mean square deviation, which is 0.036 here. You can go to the RMSD doc from Camera X for more information. So now, if this structure, if this placement is what you want, so we can delete the ground truth. If this structure, that's our fitted structure, is what you want and you want to save it, you can either go File, Save, or here we have a shortcut. You can save the structure, so we can save it anywhere. One more thing is this will not make a big difference here in this single volume that has the single structure, but when the volume is large with more than one subunit, in that case you can simulate a volume and then imagine there are other densities around this box. Then you can zero the density, and what's left is shown here. So now this is the previous volume, this is the structure, and this is what's left. So you can save this working volume, which is this one here. You can also save from the file save. So in the case of a larger volume, you can save the remaining voxels, the remaining volume, and then perform the fitting, perform another round of fitting. So in the interactive tab, you can change the, let's close this one, show both of them, and let's move it to somewhere else, just for the purpose of the demo. In the interactive tab, there is this option button. You can choose, and there are some presets. You can go with a fast fitting, a balanced fitting of the balances between the speed and the chances that you are going to find a good fitting. And the exhaustive is trying many initial placement and with a exhaustive search. And also you can save the fitting result and load it later to from the view tab. So now we are saving to the working directory, which is the desktop by default. The under that, then the DiffFit out folder and the single fit folder. You can also click select to select a different place. Now we are fitting it in a fast way, and I am clicking fit. So it does not find a correct answer. This is still from the previous one. So now we can go with the balance. With the balance, it did find the top hit with the top placement with 115 hits. We can also try the exhaustive. Exhaustive takes about 14 seconds. Previously, the balance take about 2.8 seconds to finish. So with the exhaustive, you can see the top hit. We find that placement for around 600 times. So because we have saved the result here, you can also view the result from the disk file. The target volume is here in downloads. I will need to go to the download folder. And find the path of this file. And the structures folder, we will need to put this structure in a folder. So we can put struct and place it in there. And result folder is DiffFit out, and with a subfolder, and we can click load. So now we see this. Even if we close this session, and then we open DiffFit again, and we type open. So let's put the structure here. Let's put the map here. Let's put the default output folder here, and we load it. So you can also change the level threshold and compare and examine the fitting result. So that's it for the interactive fitting. And in the settings tab, you can change some global settings of DiffFit. In our paper, we have a benchmark table, and we have reported some computation time. We are using fit atoms, all atoms, in our when we generate the table. But later we find if we use the backbone, it takes less time and it reaches a similar fitting accuracy. So you can change those global settings here. You can go to CPU, you can go to GPU. If you choose, it will show you the total memory of that GPU. And you can find the computing time in Camera X log window. That's shown before here. The total time is 14 seconds for this exhaustive fitting. If you are interested in comparing the DiffFit performance with Camera X's fitting map command, you can run this command. So let's see. So now we should fit number 2 to number 1 and search for 1000 times. Fitting number 2 to number 1 and search for 1000 times. And we'll run for a while and then show you the result. So I'm not gonna show the result. If you're interested, you can check the doc of the FitMaps doc for more and our paper for more. Thank you. If you have any questions, feel free to raise an issue here.